We'll proceed in vector and energy calculus. Vector and commercial calculus. Vector and commercial calculus, the area in which we are pursuing the discussion. So, vector and energy calculus, vector and commercial calculus, because commercialization cannot happen in a commercial way if we do not cover the energy. And mathematics cannot come to a mature way when if we do not cover the energy. Okay, that's why Sir Einstein is considered as the most pioneer scientist in recent era, modern era, post Gautam Buddha period. In the modern era, Sir Einstein is considered as the most pioneer scientist. Prior to him, there were many scientists, and if I say more to it, then he is considered as who gave everything. If you see the past, then Archimedes and Galileo and then Sir Newton and so many scientists came. But post Einstein, people did not feel that anything is lacking. Sir Einstein came because something was lacking, and the lacking was energy, discussion on energy. We cannot go discussion on mass velocity. We can do discussion on mass and velocity. Nobody is stopping us, but that is changeable. Mass can change its form. Hup, 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 hup. Mass can change its form. Once I was watching, there is a small ship. If you roam around on road, typically you will see there is a water on which there will be a small ship. It costs very less. And if someone keeps it on the water, it starts moving and then it will keep on moving without any fuel. Then I came to know there is something white color is some substance is there. I don't know what it is called, metaphor or something like that. And then they attach it, and when it comes in the touch of water, that white color substance, when the small ship, when they place it on water, when the white color substance when comes in the contact of water, it start decreasing in the size and it generates energy, and with that it keeps moving. It keeps moving till that substance is not completely dissipated. Okay, in that sense, that mass after some time it is no more. It is not there. It completely converted into energy. So mass can become invisible. An invisible thing can become mass. Mass can become energy, and energy can become mass. Velocity can become energy, and energy can become velocity. Anyway, mass may change its form. Someone has a kind of a brick, not burnt brick, okay, the raw brick. If someone burns it, then it changes its form completely. The mass idea is completely different. Anyway, there can be innumerous examples. So, mass, if you sit upon mass, it changes its form. If you sit upon velocity, then it changes its form. Whatever you see in the universe, there is a Indian epic called Gita. Gita. So in Gita, King Krishna. So King Krishna, he talks about kind of energy. Whatever you see in this universe, whoever has come will go. Whoever has come will go. So if I am someone can see me, if I have come here, then I'll go. If someone see this table, if it has come in the universe, it will go. If I see earth, then one day earth will go away. Whatever you see that has come in universe, it will go. Okay, so this proves that things changes its form. Okay, what is constant then? If it will go, this will go, that will go, or it changes its form, what is constant? Then energy is constant. Even though someone is changing its form, what remains constant across all the form is energy. If there is item kept here, if it drops like this on the earth gravitational pull from here to here, how much energy it lost? Here it has some potential energy. Here it has some potential energy. What is the difference in the potential energy? That much energy it lost. Okay, it lost in the sense that got converted into kinetic energy. So energy is the only that is constant. Otherwise, it changes. Other thing changes its form. So mathematics without energy or without vector discussion, vector computation is midway. It is not complete. Science without Sir Einstein was incomplete. Since Archimedes, I believe Archimedes came in kind of prior to Christ. Archimedes came prior to Christ, and then Archimedes or Pythagoras. So I'm just confusing. Okay, so there were many mathematicians and scientists came. And in that sense, I don't remember about Archimedes, Pythagoras, or something like that. So these mathematicians they came prior to Christ or something like that. But people felt something is missing, and that missing was completed by Sir Einstein when he talked about energy. And after that, people feel that science is complete now. So mathematics, we are in discussion for the energy. If there is an energy source, there will be a force field. If there is energy source, then there will be a force field. This is what we are talking. Force field or energy source can be path dependent and energy source can be path independent. If it is path independent, then the energy what it imparts on any particle moving from one position to another position, energy can make any particle, any item move from one location to another location. If there is an energy source, it can make a particle move from here to here. How much energy is involved moving item from here to here? That energy is liberated by the energy source. Energy source is losing energy. If this energy losing the energy source, what energy it is losing? It is only dependent upon the begin point and end point, not on the path. Then energy source is called path independent. If that energy source is losing, it is dependent upon begin point and end point rather than begin point and end point, full path what it is taking. It is taking a straight line, circular line, or whatever. Then it is called path dependent. How much it is path dependent? It can be tends to path independent. It can tends to completely path dependent. How much? What is the degree of path dependency? That is calculated by if I keep energy source for which there is a force field. Under this force field, one item is moving in a closed loop. Check how much energy this is losing and divide it by the area. This is called circulation density. Whatever comes, that shows the nature of the energy source, how much it is path dependent. Or if there is an item that is moving because of this energy source from one location to another location, and while moving, that item is rotating. If that item is making curling or torque is seen in that, then again it is path dependent. Because if I drop anything on the earth, it will fall straight, it will not rotate. Okay, in that fashion, earth is path independent. Or if item is moving from one point to another point, energy that is dissipated by the earth is completely dependent upon the begin point and end point, not on the path. Earth is path independent. In that fashion, the path dependency is how much in a closed loop, how much energy is imparted by the energy source divided by the area. That is degree of path dependence, or how much it is making curling when item is moving from one point to another point under the force field of the energy source. That curling factor, if more it is rotating while moving from one location to another location, more it is path dependent, too fast. Now, as per mathematics, the circulation density, what we talked now, the energy in a closed loop divided by the area is same as the curling factor. Okay, so energy is nothing but line integral in a closed loop. Force vector dot d of position vector calculated in a closed loop divided by the area. That is circulation density. Is same as the curling factor. If this is the force field, then this is F1, that is along x axis, and this is force field, then this is F2 along the y axis. F1, F2, this is F. In that case, in that case, now F1, F2. How much F2 is changing? This is x axis, this is y axis. How much F2 is changing along x axis? How much F1 is changing along y axis? df2 by dx minus df1 by dy talks about the curling. We have much detail in the previous video. So df2 by dx minus df1 by dy is the net curling factor. How much it is? That curling factor is same as circulation density. This is what people saw. Okay. Now it disproves that circulation density is same as curling factor. Mr. Stokes, Sir Stokes, he is saying that if you know the curling factor, and if you integrate it with the xy plane, then you will get the line integral or energy calculation again in the closed loop. Okay. So what Mr. We have demonstrated this also. So what Mr. I don't know. Okay. Okay. I have I have a cloth. I don't know how nice it would be. So if Mr. Stokes, Sir Stokes is saying that if you have a kind of a closed path, if you have a closed path, an item is moving in a closed, this item is moving in a closed path. Okay, because this it is moving because of some energy force vector is there, then this item would start rotating while moving. So it has curling factor. If you integrate this curling factor, okay, along the kind of this plane, this is forming the area. It is forming an area. If you integrate along the area, this curling factor df2 by dx minus df1 by dy dx dy integration over the circular area, then it is same as the energy what is it is making while circulating. So if I consider this as a peripheral line, then energy is force vector dot d of position vector. That is nothing called line integral. So if I have df2 by dx minus df1 by dy, d of xy plane, d area. Okay, if that is the case and integrated over this region, then that is same as if you calculate f dot d position vector. Means energy that is involved moving an item in a closed loop. This is what Mr. Stokes, Sir Stokes is saying. Not only that, he is continuing in that don't integrate directly with the d area. That df2 by dx minus df1 by dy. If this is curl factor and this is vector, if this is a vector form, dot product d of area. That make more sense. Now let's be everything in vector only. So the net, if I want the energy calculation moving an item from here and coming back to here as a line integral, then it is same as whatever is the curling factor integrated over the surface area. But more to it is df2 by dx minus df1 by dy, that is a curling factor, rotation factor, dot product with d of the dot product with d of area vector. What is area vector? If this is lying on xy plane, then area vector is k vector. If it is lying on yz plane, then area vector is x vector. If it is lying on xz plane, area vector is y vector. This is x-axis, this is y-axis, and this is z-axis. Okay. Now, if that is the case, then this is the scenario. Okay, let's move on with the Stokes. Okay, so Stokes theorem, as per the Stokes theorem, consider that I sew it. Now there is a cloth, and I sew it around this boundary completely with the needle. I sew it. Now I pull it. This is also a surface along the path I am talking about. Item is moving in this circular path. Item up. This is circular path. This is circular path. In circular path, item is moving in a closed loop path. Item is moving in a line, in a curve, and coming back to the same location. Now it is making a surface in between closed area, and the surface is a cloth like, and it is pulled like this. Now, Sir Stokes is saying that whatever the curl of the force field, now there is a force field in this region, df2 by dx minus df1 by dy. That is only in xy plane we are talking. If we talk in complete 3D, where force field has F1, F2, and F3, then dF3 by dy minus dF2 by dz I vector plus dF1 by dz minus dF3 by dx j vector minus plus can be adjusted plus dF2 by dx minus dF1 by dy k vector. Whatever this vector comes, that is the direction of curling vector. Whatever it is. So if I have curling vector dot product d of area vector. Now if this is the area vector means perpendicular to the surface. So here area vector is like this. Area vector is like this. Here area vector is like this. Area vector is like this. Okay, why you are telling like that? Means I have a flat surface. See, this is a circle and I have a completely flat surface. And area vector is all along the surface. It is perpendicular surface. The surface is flat. Now I calculated it and it gives me the line integral along the curve. What are you talking now? Now pull it. Okay, if I pull it, then how it will be same? Because item is moving in this direction only. How it will be same? If I keep moving like this and I pull it, but the net result should be same, right? Means the item is moving in a closed loop and then it is coming back to the same location. Dot Force vector dot the position vector of this curve is the net energy, net line integral. And you are saying calculate the gradient, calculate the curl of force vector. That is also independent of the surface. And then integrate with the surface area vector. Surface area vector can be flat, constant everywhere, or it can be like this, then everywhere it is variable. Of course, it kind of normalizes thing. If you pull it like this, then here area vector is like this, then here area vector is like this. Here area vector is like this, then here area vector is like this. They normalize each other, and you will get effect of flat only. Don't worry much about it. Okay, so this is the something that Sir Stokes is saying. Let's try to find out consider there is a force field. Consider, consider there is a force field called minus, there is a called force field called minus 2yi plus 2xj. There is a force field called minus 2yi plus 2xj force field. Okay, what is minus 2yi plus 2xj? That is a circular force field. Now, from the day one, you are talking about circular force field, circular force field, circular. Tell me one example of circular force field. Not possible. Okay, if I keep a magnet, okay, I used to have many magnets. Okay, I try to find again. Okay, I don't know where it went. I used to have many magnets. Okay, it disappeared. Okay, so I'm not able to trace the magnet. There used to be magnet. Okay, no magnet. Okay, so consider that I have a okay, consider that I have a magnet and magnet, consider this is magnet, then magnetic field will be all around it. Like Earth has magnetic field only. So magnetic field, but this if you see if this is a magnet and if you see the equation, then this magnet has magnetic field like this all around. What is the equation of this magnetic field? Xi plus yj, because this is radial. If this is a magnet, then everywhere it will be toward the center of the magnet. This is radial, that is xi plus yj. What is the magnetic field? If I talk about a magnet that is a kind of a sphere, then magnetic field will be xi plus yj plus zk. divided by whatever it is. But that is the direction of the magnetic field. Similarly, the Earth magnetic field is also proportional to r vector divided by r to the power 3 minus r vector divided by r to the power 3. Proportional to, there would be some constant. R vector is xi plus yj plus zk divided by r to the power 3. Okay, x square plus y square plus z square to the power 3 by 2. That is the magnetic vector of Earth gravitational pull. Okay, if that is the scenario, now consider I have a magnetic field that is minus 2y minus 2yi plus 2xj. That magnetic field, this is x-axis, this is y-axis, minus 2yi plus 2xj. If I consider this, then if y equal to 0, that is x-axis, then it is xj. More I move along the x-axis, the power of the magnetic field is growing, but it is all along the x-axis, it is in j direction. If I talk about y-axis, then x is 0, then it is minus yi. Means if I go along the y-axis, the power of magnetic field will grow, but it will be in minus I direction, this direction. If I take point 1 comma 1, then it is minus 2i minus or minus I plus j, minus I plus j, minus I. If I take 1 comma 1, minus I means in this direction and j in this direction, it will be in this direction. It looks like tangent at any point in the circle. So it is a circular magnetic field. Tell me one example of circular magnetic field. Okay, I'm certainly now going to bring one electrical wire. That much I can do. Okay, okay, I have one electrical wire. This is electrical wire and I am going to plug it. If I plug it, then this wire, consider this wire is in z axis, along the z axis. This is x axis, this is y axis, this is z axis. This wire is along z axis. The wire is along z axis. If electricity is flowing through the wire, then it will produce magnetic field, certainly. If you have magnetic field, it will produce electricity, certainly. This is how dynamo works, where you have a magnet that is rotating inside a copper coil. You have magnetic field, and then if you move, it will produce electricity. If electricity is flowing all around the electricity, there will be magnetic field, certainly. So if there is a wire like this straight, then there will be around it, there will be a magnetic field. Now magnetic field is circular. The people would be happy on me that magnetic field is certainly it is circular. What is the equation of this magnetic field? Some constant, I believe 2I by C, where C is the speed of light. 2I by C means it is very less. If I is 1 ampere, that is high current. In electronics, 1 ampere is very, very high current. So 2I by C, if I don't know, it is something like that. I by C means it will be 10 to the power minus 9 or something like that. That much is the magnetic field strength into minus yi plus xj. That is circular direction around the wire. If wire is in z direction, then it is circular like this. If it is like this in x-axis, then it will be in yz plane, the magnetic field will be. If it is in y-axis, the magnetic field will be in xz plane, circular. So circular magnetic field is possible. So the equation would be some constant minus yi plus xz divided by x square plus y square. This is the magnetic field. But anyway, we are talking about a magnetic field is minus 2yi plus 2xj. That is the magnetic field. If this is the magnetic field, or consider minus yi plus xj, now it is simple. Minus yi plus xj. Now use Stokes theorem. Now this is the magnetic field. This proves that magnetic field is in xy plane. This is xy plane. This is x-axis. this is y axis, and this is z axis. Magnetic field is in xy plane. Magnetic field is in xy plane. In that case, now consider the circle. I have a circle in YZ plane. An item is moving because of this magnetic field. Magnetic field in XY plane. And a circle is lying on YZ plane. YZ plane moving in a closed loop. Now tell me through with Stokes theorem how much is the energy, that energy source. Because of the energy source there is a magnetic field called minus yi plus xj. Because of this magnetic field, force field, how much energy the energy source is losing when item is moving in a circular fashion from here and coming back to here in yz plane. If I don't take Stokes theorem, then simply someone would calculate the force vector dot d position vector by the circulation density. I believe this will be all right also, but calculating the net energy through the curl vector integrating along dxy plane and then integrating, that will give some absurd result, because curl vector df2 by dx minus df1 by dy, df2 by dx, df2, f2 is x, df1 by dy, f1 is minus y, 1 minus minus 1, 2. 2 integration along x and y in a circular region. So integration x and y in a circular region means we are calculating area of the circular region. That is pi r square. Pi r square into 2. Pi r square into 2. I believe so. Okay. Pi r square into 2. So pi r square into 2. That much is the circulation, that much is the net energy calculation, not circulation density. Circulation density is 2 only. That is the curling factor. Now let's go with Sir Stokes theorem. Now he is saying calculate the curl vector. Calculate the curl vector dot d of area vector. So curl vector is df2 by dx minus df1 by dy k vector. Curl vector is determinant of a matrix where first row is I, j and k, and then next is d by dx, d by dy, and third is f1, f2, f3. f3 is not there. So I'll take third column and first row and calculate the determinant. Then it is d by df2 by dx minus df1 by dy k vector. df2 by dx, no, it is 2k. 2k dot product with d area vector. Area vector is, if this is the circle, then this is the area. Area vector is along the x-axis. So now it is dx dy along I vector dot product to k vector. K vector dot I vector is 0. There is no energy calculation at all. So Stokes theorem is complete thing in calculation of energy, where we consider the area vector also. If I tie a cloth and pull it, then all around the area, now you have to get the area vector in algebra, and then you can go with d of the area vector. Okay, anyway, now this is lying on xy plane. Now tell me. So lying on xy plane, df2 by dx minus df1 by dy will be same 2k. 2k dot product with the area vector along k side. If this is area, then its vector is along k. K dot k is 1. So alright. Now 2 dx dy and integration over the circular region, that is a circle. Okay, that is x is minus a to a, x is minus a to a, and y is minus a square root of a square minus x square to a square minus x square. I believe it will make it complete in this fashion. So if that is the case, 2 I can keep outside. I integrate with y, dy first, then it will come as y, and y minus and plus, it will become 2 square root of a square minus x square. 2 I can keep 2 2 I can keep outside. 2 anyway it was outside, it become 4 now. It become 4 now. So 2 square root of a square minus x square. So that is now, what is integration of a square root of a square minus x square dx. Okay, let's consider x equal to a cos theta. Then the square root of a square minus x square becomes a sine theta. A sine theta, a sine theta, d theta. A sine theta, a sine theta, d theta. Okay, now someone can proceed on it. It will come as sine square theta. Will come as sine square theta. A sine theta, a sine theta, a square. A square sine square theta. Integration of sine square theta is theta by 2 minus sine 2 theta by 4. This is what I believe so. Angle is 0. Angle is 0. Okay, angle is, how much is the angle? Okay, angle is that x is minus a to a. So x equal to a cos theta. If x is minus a, then cos theta is minus 1. That is pi. Okay, if x is a, then cos theta equal to 1. That is 0. 0 to pi. So 0 to pi means it will become pi by 2. Pi by 2. So pi by 2 into 4a square, I believe so. This is what I remember. So 2 pi a square. 2 pi a square. Same thing, right? We calculated earlier also. So 2 pi a square is the net energy that making item move. The energy source is losing, making item move in a circular direction. Now Stokes theorem is considered as a complete. We'll proceed. Actually, I thought of completing this electricity example. There's an electricity example we took. It has big history. It is not that simple. So that we will take. I thought, but this is very complex. Stokes theorem is very powerful. So idea is, can we calculate energy calculation of an item moving in elliptical shape, x square plus 3y square, 3y whole square, x square plus 9y square equal to 9. If this is an ellipse, then how much is the energy computation of, if there is an electrical wire like this and I have elliptical region that is around the wire, not circular region, elliptical region around the wire, and that is x square plus 9y square equal to 9. In that sense, if any item is moving in a closed loop fashion in ellipse from one point and coming back to the same point, how much is the energy dissipation happening from the current that is moving in the wire? If current moving in the wire is making an item move in ellipse region, then how much energy it would lose? If I am if I am running a wire and current in that, and if I make something move around the wire, then current will not reach same what I am pushing from here, because energy is dissipated in moving item. This is something called energy loss through the power transmission. So in that sense, what is the solution that we will talk? You would have seen 11,000 volt. Why 11,000? Anyone uses 11,000 volt in the electricity transmission? Big tower comes into the picture and current moves through 11,000 volt. 11,000 volt. But in household, energy comes at 220 volt only. Then why they push energy through 11,000 volt? Okay, I believe the answer is hidden here, but we will see more into it, that magnetic field generated by the current movement, and that if I make any particle move in an elliptical fashion because of that magnetic field, that how much energy it would consume through Mr. Stokes, Sir Stokes theorem. So please do support us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. We will see one more session, I believe, in Sir Stokes theorem.